So hello everyone, welcome to another part of the 2026 IIT JAM question solution. So today we'll solve the MSQ section. So let's start from the question. Which of the following ore types form or forms by magmatic differentiation? So what is magmatic differentiation? So differentiation is a process by which a single homogeneous magma can split into two or more different compositions. So it is occur during magmatic crystallization where solid and liquid can separate, liquid and liquid can separate to different or to contrasting composition to produce, you can say, diversity in magmatic composition, which leads to different type of rock. So in this question it is asked, which of the following ore types that forms by magmatic differentiation? So any ore type that produced by magmatic process, they always produce a magmatic differentiation. So first option is given, gold in quartz vein. So always remember, if you in any type of question, if you any type of ore deposit question, if you encounter the word vein, very important, if you encounter the word vein means, so what is the meaning of vein? It is precipitation. It is precipitation along a fracture. So this thing belong to hydrothermal. So hydrothermal means any hot water that enriched in mineral, when it will get deposited along a fracture, that is called as your vein. You can take any hydrothermal solution when that temperature will decrease and it will deposit along a narrow or elongate fracture. That fracture is filled with economic mineral. That deposition is called as your vein and it belongs to hydrothermal. That means that gold deposition in a quartz vein will be considered as hydrothermal. That means this option is incorrect. Then comes to next option, that is your titaniferous magnetite in anorthosite. So there is a fundamental thing where any deposition that occur at a very high temperature, that basically formed by magmatic concentration, because hydrothermal has a temperature that ranges from 50 to 500 degree temperature. So here we have titaniferous magnetite. So titaniferous magnetite, that titanium, vanadium, then your niobium, tantalum, columbite, these are depositions that occur because of magmatic differentiation. When there will be crystallization, with progressive crystallization, if the residual melt that become enriched in incompatible element, so that incompatible element, when that residual melt when separate from the rest of the solid, then that become enriched or become more richer in particular or certain elements that give deposition or that give an economical deposition. Here titaniferous magnetite means your titanium with magnetite that deposit in anorthosite. So anorthosite, it is produced at a higher temperature, because anorthosite is a rock that composed of labradorite, which is produced at a higher temperature. So this titaniferous magnetite, if you will find in anorthosite, that will indicate an magmatic concentration deposition, where titaniferous magnetite produce or remain as residual melt and deposited on a host rock, that is called anorthosite. So it will belongs to magmatic deposit. Then columbite and tantalite in pegmatite. So the pegmatite, it is produced by highly hydrous rich felsic magma. So that also produced by your magmatic differentiation, where residual melt are richer in various trace elements. From that, columbite and tantalite is very important, because columbite and tantalite contain also uranium. So that's why in pegmatite bodies or pegmatite deposition, you will get coarser grain, and also you will get this columbite and tantalite deposition. That's why pegmatite is also considered as magmatic deposition or magmatic differentiation. Then chromite and pentallandite in pyroxenite. So pyroxenite is ultramafic rock, chromite is always associated with ultramafic rock, and if you hear the word chromite in any ore deposit, that must produce by a magmatic concentration deposition, and that be maybe in a segregation deposition, or you can say a differentiation deposition. So that's why these three are true for magmatic differentiation. So the answer will be B, C and D. So next comes to another question: which of the following factors affects the intrinsic spatial resolution? So what is a spatial resolution? So spatial resolution means how detail you can detect an object. Suppose you are taking a picture. So if you taking the picture far from the object, then the detailing of the object will be missed, depending upon the camera. So if you are taking picture at a nearer range, then detailing will be there. So that detail determined by the spatial resolution. So think of a spotlight. So if you using a spotlight, if you using at a very greater distance, then it can cover a larger area. But if you are using at a smaller distance, it will cover a smaller area. So smaller area means more detail. Larger area means if you are using a spotlight to detect an object from a greater distance, then it will cover a larger area, but the detailing will be missed. That's why during remote sensing work, your flight or something or satellite, the ray comes from the satellite that cover a certain area. So just imagine about the spotlight. The distance will determine how much area the spotlight will cover. That's how the distance will cover determine how much area a remote sensing object or sensor will cover. So that's why the distance, that means in this case we are spotlight, we are using the distance. In case of remote sensing, we are using some spatial or from a height. That's why the altitude will matter. So the altitude will determine how much area it will cover. This is called as IFOV, instantaneous field of view. That is called as a pixel. That is called as a pixel. So any object that is more than that is larger than the IFOV, that will be easily studied, or you can say can be studied in detail. Any object that is smaller than the IFOV cannot be studied in detail, or any object or objects you can say within IFOV cannot be distinguished. So that's why this also matters. So this is called as your pixel. This is called as your pixel. Pixel means a picture element. So any picture you divide them into smaller squares, where each square give you details. So the less the picture size, that means you can obtain more detail about any terrain or anything you are studying. So the more the less pixel size, the more the higher resolution, more the larger pixel size, more the lower resolution. So that's why the picture size and altitude of the satellite, they eventually affect the spatial resolution. Then you can say wavelength also, but it is in you can say in context of physics. But in case of remote sensing, it has a very it does not directly affect the resolution. So that's why the answer will be A and C. So let's move to another question, where in the following illustration PQRS, so you can see PQRS is an exposed axial planar cleavage. So first thing, what is axial planar cleavage? Suppose we have a fold like this. So this can be our axial plane. Okay, so this can be our axial plane which divide the fold into two similar half. So the cleavages are produced parallel to the axial plane. that means the axial plane cleavage follow the axial plane. That means it follows the attitude of the axial plane. Follow the attitude of the axial plane. So now we have axial plane cleavage, that is PQRS. That is striking north south. So the PQ, it is along north south direction and it dips at about 40 degrees. That means if the axial plane cleavage dip 40 degrees, that means the axial plane also dip similarly to the axial plane cleavage. That means the axial plane is inclined. From this statement you can see the axial plane is inclined. Then your B1, B2 are the traces of the two folded bedding planes on the axial planar cleavage. So the axial planar cleavage has on the axial planar cleavage we have a traces of two folded bedding surface. So let me draw a diagram. Suppose we have a fold like this. We'll have an inclined fold. We like this. Now this is our axial plane. Okay, this is our axial plane. Now this is your limb and this is your limb. So it will make a trace like this. If you are talking about this type of fold, then the trace will be like this. So if the trace is inclined to the strike of the axial plane, that means the fold is plunging. And as the axial plane cleavage that follows the axial plane, that means any bedding trace that is, you can say, inclined to the strike of the axial plane cleavage, that also plunging. That means the fold is plunging and axial plane cleavage is inclined, that means axial plane is inclined, that means the fold is inclined. So upright fold will not be correct because the axial plane cleavage is inclined. Upright fold when the axial plane is vertical, that is 90 degree. Horizontal fold when there is no plunging. Here the fold is plunges, so that's why it is not a horizontal fold. Then inclined and plunging, these two options will be correct. So inclined fold and plunging fold will be correct. So come to next question, that is your two sandstone reservoir rocks R1 and R2. So we have two rocks, that is R1 and R2 have 25% porosity each. So we have R1 and R2. But the permeability of R1, so you write down like this, कि permeability of R1 is greater than permeability of R2. So permeability of R1 is higher than the permeability of R2. So keeping this statement in mind, which of the following explanation will be correct? So first, R1 has more angular grain than R2. So first thing you remember that R1 is more permeable than R2. R1 is more permeable than R2. If R1 is more permeable than R2, then first statement is saying कि R1 has more angular grains. So always remember कि we'll take the example of breccia and conglomerate. So breccia consists of angular grain, conglomerate consists of rounded grain. We all know कि conglomerate is more porous or permeable than the breccia. Whereas angular grain that reduces the porosity, and you can say कि permeability. So if R1 is consists of angular grain, then it should have less porosity or permeability than the R2. So this will be incorrect. Then your microfracture density in R1 is higher than R2. So microfracture density, it is a thing where it can develop permeability within the rock, because there are different type of permeability that produced during the rock or during the formation of the rock, that is primary porosity. It can produce permeability after the formation of the rock. Those rocks are more crystalline, or you can say igneous rock, they have permeability because of the formation of the fracture. So the fracture that enhances permeability. So you can say microfracture density of R1 is higher than R2. It can be a feasible option. So this will be correct. Then clay content of R1 is more than R2. So we all know clay is highly porous but impermeable. Though if suppose we'll say R1 has more clay. So in context of R1 is more porous than R2, it will be correct. But in context of permeability, it will be incorrect. Then sorting in R1 is better than R2. So sorting means it is distribution of grain size. So if any rock contain a similar grain size, then it is more porous than a rock that is ill sorted, which consists of different sized grain. So that's why it can be a cause R1 will be more permeable than R2. So these two will be correct, B and D. Then comes to next question, that is choose the correct statements related to different aspects of volcanism. Choose the correct statement related to different aspect of volcanism. So first statement is given, pillow lava reflects subaerial volcanism. So this is a tricky statement, you can say. We always remember that pillow lava produces subaqueous condition or submarine condition. So if you are not conscious enough in the exam, then you will pick the word sub, then you can choose this as a correct option. But if you see it carefully, it is written as subaerial, below the air. That means it is not a pillow lava condition. It is any volcanic condition that is produced on the surface. They are subaerial. So it is not exclusively pillow lava. It will be incorrect. Then your explosiveness of volcanism depends on the viscosity and fluid content of the magma. So explosiveness means there are two types of magma we have studied. That is, one is your fissure type, one is your central type. So central types are more explosive, fissure types are more quiet type, you can say. So quiet type magma, in quiet type magma, always remember there is volatile matter, but they are in free condition. But in explosive type of magma, their volatile content, they are trapped within the magma. So any magma that is, you can say, explosive, they are under high pressure. And take the example of a cold dish bottle. If you open and cold dish bottle, then it will produce some noise or produce some sound, then produce some your bubbles. That indicates the release of, you can say, gases. So any magma that is charged with gases, any magma that is charged with gases, that when it will erupt to the surface, it releases its gas, producing energy in terms of sound. So that's why any magma that has high viscous and fluid content. Viscous means mostly in case of felsic magma, all the volatile matters that present in dissolved condition. So that's why they are high viscous. So felsic magma are high viscous and they have fluid content. When they come to the surface or they produce volcano, the volcano will be explosive. And also felsic magma produced at a lesser depth, they are under direct pressure of the rock or direct pressure of the overburden. So that's why the volatile matter that present within the felsic magma are in dissolved condition. When any fractures or any other breaking will occur, they will produce volcano which will be explosive. So that's why B option will be correct. Then shield volcano represents one of the largest magmatic vent landforms. So in volcanic landform category, there is a category called cone, volcanic cone. So it is a positive relief feature. So in that you'll find cinder cone, you'll find stratovolcano, you'll find your this shield volcano. So the smallest is your cinder cone, but it is steeper, but it is smallest. Then the catastrophical one is your stratovolcano that will uh, indicate the last option. The silts are the most andesites are the most common rock type associated with stratovolcano. Stratovolcano means it is producing both pyroclastic material and lava in a rhythmical manner. The stratovolcano that produce along convergent plate boundary. It produces along convergent plate boundary, and it is more explosive, and it as it is produced along convergent plate boundary in continental and ocean condition, so that's why the composition will be intermediate, that is andesite. So this option is correct. Now come to this thing, that is sealed volcano. Sealed volcano are only consist of lava material. So lava material are more, you can say, more volatile. They because of this less viscosity condition, they can spread to a larger area. So they have very less slope, around, you can say, 5 degree to the bottom, and to the top it approximately 8 degree, or you can say the slope in between 5 to 8 degree. So, but this covers a very large area. This is very broad. That looks like a shield. You can say a that shield that you use in war. So that look like a shield. So the area wise it is very large, but it has a very gentle slope. So that's why this option will be correct. So shield volcano represents one of the largest magmatic vent landform. It will be correct. And andesitic are the most common rock type associated with stratovolcano. It is also correct. The stratovolcano, it is why it is called strato, because the word strata indicates it consists of both lava and pyroclastic material layer by layer. So it is called as a stratovolcano. So next come to another question, that is the Earth's gravitational acceleration is higher at the pole. So force of gravity, gravitational acceleration, it is inversely proportional to the radius. Inversely proportional to the radius. So our Earth is oblate spheroid, so it has a greater radius near the equator and a smaller radius at the pole. So around 6378 kilometer at the equator and 6356 at the pole. So as the gravitational acceleration due to gravity, it is inversely proportional to the radius. So pole has more gravitational force than equator. That is one cause. So you can simply choose the shorter polar radius. It will be one option. Then we'll examine other option. Higher topography at the poles. So topography is a very local thing. Higher density of the rock, it is also local thing that doesn't affect the whole things. So that's why this can be considered to variation of your gravitational field along the latitude. So then comes to other options, that is lower centrifugal acceleration. So that is centrifugal acceleration, centrifugal force at the pole, centrifugal force at the pole is zero. So what is the centrifugal force in context of gravitational force? So the acceleration of gravity that try to pull any object to the earth. Centrifugal force, it key object that move or thrown away from the earth, you can say. So that means the centrifugal force that counters the gravitational force, that reduces the effect of the gravitational force. So as in polar region, at the pole, you can say the centrifugal force is zero. That means the gravitational field will be higher, which is opposite in equator, where there is centrifugal force is maximum, that reduces the effect of acceleration due to gravity or gravitational acceleration. That's why this will be also correct. So answer will be C and D. So next comes to another question, where during glacial retreat following the last ices, that means there is an ice age. Then after the ice age, the glaciers start to melt. That is an interglacial period. So Scandinavia experienced isostatic rebound. So during your glacial period, what happens? Okay, the suppose in Scandinavia, you can say the crustal part, it is covered by ice. So because of the load of the ice, the crust will depressed. So that is in ice, your ice age. So when the ice will melt, so here it is saying during glacial retreat, retreat means melting of the glacier. So when the ice will melt, then the load will decrease. So when the load will decrease, the crust will start to uplift. That means any glacial retreat following an ice age. So here the region is given Scandinavia. The crust will start to uplift. Then come to the option deep earthquakes. So always remember deep earthquakes only associated with subduction zone. You all know the deep earthquake only it is found in subduction zone. In any other region, you'll never found deep focus earthquake. So that is obviously incorrect. Then raised beaches. So beaches are on the land. So as the coastal part is uplifting, that means the land part is also uplifting. That means you will get a raised beach. You will get a raised beach. So this will be an appropriate option. Then rise in water level in glacial lake, fall in water level in glacial lake. So either one will be correct. So let's think if the land will uplift, if the land will uplift or the crust will uplift, so it will decrease the water level. If anything depressed, then it decrease the water level. If anything uplifted, it will decreases the water level. So that means that will be fall in water level in glacial lake. So answer will be B and D. It will be B and D. Then comes to another question. So intrusion of a 10-meter thick dolerite dike into boron rich quartz granite biotite muscovite chloride schist developed in visible symmetric baked zone. Baked zone means that is your you can say contact nodules. You can say contact nodules. Which of the following minerals can develop in this baked zone? 2 meters away from the margin. 2 meters it is simple. Even for confusion, 2 meters means it is within the contact nodule zones. That means still that intrusion it is affecting that much of area. So we have boron rich fluid. So recently I have made a YouTube source about this thing. That is in Kanakund. That is your Grand Canyon of Odisha, we call that. So in that region, uh, you'll find that boron metasomatism. That is in that video. You can check that in our YouTube shorts. So when there is boron metasomatism, you will get tourmaline. You'll get tourmaline. So if you seen that video, then you can easily solve this question. Those who already is in that, they can easily answer this question and JAM exam. So we have a boron rich fluid means that will produce tourmaline. That will produce tourmaline. So any boron rich fluid when it intrude to any fractured granites or here we'll say quartz, granite, biotite, muscovite, chloride, schist or any metamorphic rock that is in granite, they will produce tourmaline. They will produce tourmaline. All other options will not be correct. These are produced in different condition. So always remember boron rich fluid when metasomatized it produce tourmaline. So it is will be tourmaline. So always remember MSQ does not means that more than one option will correct. MSQ means one or more option will be correct. So that's why you'll get one option. Only one option is correct here. So next comes to another question. That is your it is about your magnetic polarity. So which of the following processes is or are responsible for the alternate bands of magnetic polarity observed in seafloor basalt? So alternate bands of means that is reversal of polarity. So the reversal of polarity it is caused by magnetic activity which is caused by any convection activity in the outer core. So magnetic property that develop within the earth because of convection within the outer core, and because of that we'll get that magnetic polarity within some year or time. So that is called as magnetic cone. So this will be correct. Let's take another other option. Seismicity it doesn't relate it to any magnetic activity. Convection in the inner core, there is no convection in the inner core because the inner core is solid. Convection in the mantle does not affect the magnetic polarity. So still only one option will be correct. Though it is an MSQ, but you will get only one option is correct. Then comes to natural accumulation of hydrocarbons are expected to occur. So these are called as your hydrocarbon traps. So in syncline you will not get any traps, but in stratigraphy there is stratigraphy trap, that is anticline trap, that is delta mouthward trap. First thing, why syncline doesn't have any trap? Because they see this is a syncline and this is an anticline. Okay, we know petroleum it tends to migrate upward. It tends to it always accumulate above the water, you can say. So in the place where it is accumulate, it always needed seal rock or always need something to trap it. So we does not found, or the syncline is structurally not designed to accumulate the petrol. So petrol can easily migrate upward because there is no suitable thing here. So that's why in syncline you will never get any trap. Then stratigraphic trap. Stratigraphic trap means there is older, younger rock. There is unconformity, where you will get paleosol deposition, where you will get clay deposition, which can accumulate or which can trap petroleum. So petroleum trapping means it always required an seal rock which is impermeable, which can possible in case of this unconformity situation. In anticline, if this is impermeable, then it can easily accumulate petroleum here. Then delta mouth bars, that also a region where you'll get your clay sediments which is impermeable. So that also can trap your petroleum. So B, C and D will be correct and A will be incorrect. So this is your full solution of MSQ section. So the next video will complete the MCQ part.